Good afternoon, sir.
Good afternoon, sir.
Yeah, all the participants, welcome to last day of short-term training program MATLAB. Sir, with your kind permission, I am handovering to you, sir. You can take over the session, sir.
Yes, sir. Yes, sir.
So all the
So welcome.
participants, please keep mute. Thank you.
Good afternoon to all. Welcome to the last day of the hands-on training in MATLAB. Sorry, I'm just muting all. Yeah, fine. So in today's lecture, I'm planning to cover graph theory topics, some missing topics in calculus, like Fourier series, Fourier transforms, Laplace transforms, Taylor series, and general series. How do you find some of the infinite series or maybe finite series, and vector calculus? Along with that, some statistical topics I'm planning to explain, like simply find mean, median, mode, standard deviation, variance of the data, correlation, and probability density function for different probability distributions like binomial, Poisson distribution, normal distribution. How you find? I'll give a basic idea. So based on that, you can extend the topic and you can uh, improvise the topics till what you are expecting. Now let us see. Let me share the screen. So before starting, any doubts regarding the earlier topics, just message in the chat box. At the end of the lecture, I'll try to cover or I'll try to clarify your doubts. So hope the screen is visible, right? Is
Yes,
anyone
sir. Visible,
confirm?
sir.
Yeah.
Yes, sir.
Yes.
Visible, sir.
Yes, sir. Fine. You can see, so first I'm planning to explain these vector calculus. How do you find gradient, divergence, curl? And based on that, you can just search for the remaining Hessian matrix. How do you find Jacobian, Laplacian of the scalar function? Whether the given set of functions are Laplacian or not. Like means dou square u by dou x square plus dou square u by dou y square is equal to 0 or not, like that. How you can verify? Or otherwise, suppose if curl is 0, then the potential scalar potential is possible or not for certain vector field. If so, what is that? How you find and vector potential? So these are not I'm explaining. Just I'll give the brief idea about what is gradient, divergence, and curl. The same thing you can extend to further. Okay. So the same, this is also the symbolic mathematics. Now I request the participants to open the MATLAB software. To open the MATLAB software. So vector calculus, gradient, divergence, and curl. This is gradient, divergence, and curl. How you are going to find this? The same, let me zoom it. I don't know whether it is, yeah, fine. Now it is very clear the topic wise, content wise, the input and output are in terms of variables only. That is why I'm planning to define X, Y, Z as symbols. X, Y, Z as symbols. Now F is equal to suppose X square, Y cube, and Z power 4. I'm just taking one scalar point function. For that only gradient is possible for the scalar point function, right? Now this is. Now I'm just taking with respect to what vector you are planning to find the gradient. That means we are defining with x, y, z. With respect to x, y, z, we are planning to find the gradient. We know that what is the formula of the gradient, and here you can see what is gradient formula. It is simply gradient of the function with respect to x, y, z. You can see what we'll get. So this is first one is I component, second one is j component, and third one is k component, like this. First one is I component, j component, and k component. So this is how you find gradient of f comma v, gradient of any scalar point function with respect to x, y, z. Yes. See here, the output is also in terms of the variables, right? You can execute, the same. Next, I'm planning to take, suppose, capital Z x into e power minus x square plus, sorry, minus y square. I'm just taking, this is a two-dimensional expression. For these, I would like to visualize what is the gradient. Geometrically, we know that the gradient is nothing but normal to the scalar point function. Normal to the scalar point function, right? So that is why I will try to draw first what is the surface of z is equal to x e power minus x square y square. Why I am taking two-dimensional means four-dimensional visualization is difficult. But if suppose a function is in terms of two variables, then we can visualize its output with a three-dimensional diagram. That is why here I'm restricting with only two variables. If you want to try this, we need the four dimension. The four dimension visualization is not at all possible in reality. So in reality, only the three-dimensional space. That is why I'm taking like this. X star e power minus x square y square. But here we want what is x value, right? So same, this is related to two-dimensional. In previous, when we drawn the plots, we discussed about how to draw three-dimensional diagrams using the mesh grid, right? Mesh grid. So here -2, step size 2, like this, suppose I'm taking, right? Now the function is in terms of x, capital X, and capital Y. This is, you can take x comma y. Yeah. Functions. Now contour, I'll just take what is x, y, z, what we'll get. I'm sorry, something is wrong here. These are vectors, right? So that's why let me take x dot. Yeah. Element-wise product I'm taking. I'm just simply changing here x dot square, y dot square, even the starting also x dot 2, right? Now you can see what is the graph of x into e power minus x square plus y square. This is the graph. X into e power minus x square plus y square. This is. Okay. Now we need to find gradient. We need to find gradient of this. Gradient of z. And these, what we do, dx, just simply dy is equal to gradient of z. Now, what you can do here, contour x, y, dx, dy. I'm just correcting it to draw exactly for this. Misgrade, everything is correct only. I'm just no practice. Let me check. Yeah, sorry. We need the vectorial representation for this. It's not like the curves like this. Yeah. QUIVER. Yes. But see, both graphs are appearing in different. If I'll merge both, let me take here what I am doing. So I'm just taking hold on. You can see both. We know that what is the gradient? Gradient is normal to the surface, right? So because gradient is a normal to the surface, you can observe the solid lines are the curves for the function, scalar points. And you can see the vectorial representation. To get the vectorial representation, the syntax is QR. The syntax is a QR to plot that. So this is normal, how to draw the normal. This QR is a syntax to draw vectorial plots. And here it's very clear that wherever you take the point over the curves, you can see these vectorial representations are normal, perpendicularly coming out of that. So that is what is the meaning of gradient. Physical, geometrical interpretation of the gradient is normal to the surface. So this is the meaning. Okay. So the same way you can practice the remaining. Now I will give for the same, suppose this is for the same function, I'll try to give divergence in place of gradient divergence. But for this, for what the divergence is possible, divergence is compatible only for vector fields. Arrow is in different directions for right side and left side. No, it's not matter of left side and right side. That is a complete negative and positive. We took the domain negative and positive. That's why it's coming. If you want to take a complete positive, you take. According to that function, it comes like that. See, you take sine of e power xyz in place of that, then you can try. See, this is a z into e power minus x square y square, right? Suppose I'll take sine x y square, suppose. Let me take capital. You can see what we'll get. This is, that will be the different. It all depends on what the curve it is. Can you explain the answer of first one? You mean this one, gradient?
Yes, so that answer actually 2xi plus 3y squared j, like that we have to get. I'm not getting this form. It's a matrix form.
No, this is a vector form only. For 2x y cube z power 4 is I component. 3x square y square z power 4 is j component. 4x square y cube z cube is k component. Is that clear, right?
Yes, sir. Yes, sir. Yes, sir. Now
Yeah.
it's clear.
Yeah. Okay, now let us find the divergence. To find the divergence, we need to take the vector. To find the divergence, we need to take the vector. The vector we take within the square brackets. We know the vector is also like row matrix. You can write in terms of the row matrix. So that's why suppose x square into y. Next, x, y, z. The second one is suppose sine x, z square. I'm just defining the function. X square y is I component of the vector field. XYZ is a j component of vector field. Sine of x z square is a k component of vector field. So these vector field with respect to xyz directions, we are finding divergence. Now this is, we know the divergence is scalar product that will give the scalar value. That is why it is giving the scalar function. That is why it is giving scalar function. Like this. Next, for the same vector field, suppose I would like to find curl simply. This left side, I'll take just definition. Yeah, you can see what is curl of vector field. Curl of vector field. Simply, but this is the syntax for divergence. This is the syntax for curl. Okay. So on the remaining, finding Laplacian or maybe other things, just Google it, you will get. I'm just giving idea of finding how for these. Basically, these are the three main basic properties in vector calculus with which we start. Yes. Now, this is Riemann sum series, Taylor series, or systematic sum of the series. How you can find? So this is these are the syntax. Suppose these are the problems. So the first one is just like sum of the first n natural numbers. Sum of the first n natural numbers. Let us find sum of these series up to infinity or maybe the finite one. The both will try up to infinity or up to certain value. So both we can find here. Okay. So first here, what is the function? Here function is simply k. Function is simply k. Okay. But we need to define this k as a symbol. Next, the value, series value, suppose SYM sum of f, comma, variable. Here we are taking k. But what is the starting point of the series? 0. 0 to certain value, suppose. This is 55. Or otherwise, suppose you take x value, this is x only. Now, this x from 0 to k, if you take like this, then k also you define as a variable. You can see the formula. 0 to certain k value. So, f is the function. Function is in terms of which variable. The summation starts from 0 up to k value. This is, if suppose in place of k, you give any finite value, then it will give the result. The same thing, we'll try the next, another one with infinity topics. Yeah. So same x, f is equal to 1 by x. Sorry, you take 1 by x square, suppose. Yeah. 1 by x square. Summation value, same. fx0 inf up to infinity. So here f2 summation 1 by k square, k runs from 1 to infinity. For that we are trying. You can see the value. Singularity. Okay, from 0 it won't work. That's why from 1 to infinity. Yes. From 1 to infinity we did. Because if you start with 0, 1 by 0 square, 1 by 0 is undefined, right? That's why it is not giving the result. So series value pi square by 6. So any complex series, you can find easily what is the sum of the series. Infinite series or finite series. So this is how you can find for these. Okay. So, and this is also, how do you find the product? I'll do one for one, maybe P 2k minus 1 by k square, symbolic product. X and k, the function is equal to 2x minus 1 by x square and product value. Function variable starting from 1 to k. I think from 0 also you can find this. Yes. Okay, so why it is giving NaN? That means not a number. If you start with 0, gives undefined value. That is why it is giving a not a number. Then you start the series with 1. Then this is the answer. 2 power k plus 1 into 2k factorial by 2 into 2 power 2k k factor lol q. So this is a finite sum of the series or finite product of the series, infinite sum of the series and infinite product of the series. How you can find using MATLAB. Pardon? Hello? Someone is trying to ask something. So next one, Taylor series. So here, symbolic mathematics. So x we are defining as a symbol. Now the function f is equal to sin x. Just simple expression I am taking. Say y only sin x means if you want to take x sin x, you take any function. Now we need to find function x Taylor series of f comma x. We can see x square minus x power 4 by 6. We are not defining the Taylor series about which point we are finding. If that is the case, by default, it will take it as a Maclaurin series. If suppose you will give about pi by 2, you are finding this is the value. Taylor series for the function. Taylor series for the function about the point pi by 2 or pi by 4, whichever you want, you can take. So pi by 2 or pi by 4. You can see here, it is showing till power 5 only, is right? But if you want to execute order, if you want to execute this, the order, that order also you can define. It's like order up to 7 if you want to find. You can see here, it will show till 7. Next, I'll take 10 suppose. You see, till 10th order it is giving. Till 10th order it is giving up to 10th. Or maybe 20 you can give. Up to 20th order it will give. You see 17, 18, 19. This is how you can find the Taylor series easily. This is F1, yeah. Okay. Even you can change the point. So pi by 4, you will get easily about pi by 4 or maybe pi by 3. Maybe pi only or simply 0. So whatever the point you can find easily, right? So to explain the graphically the same thing, let me take the simpler one. F is equal to sin x and this is about pi by 2, right? So let me take only up to 5 order, F1. Next, F2 will be up to 10th order. F3 is equal to the maybe till 20th order. You can see different files. F1 is only up to 5th order. Next one is at 10th order. Next 20th order like that, right? But graphically, what it means? Let me take the function plot of f. Function plot of f. These are overlapping previously. That's why it's, yeah, now it is fine. Okay, so first let me execute this. Then it is, right? Function plot of f. Now, next what we do? Function plot of f1. Function plot of f2. Function plot of f3. You give the different colors. This is the red one. Next, this is blue.
Guru.
Next, this is green. This is black. So let me take here, hold on. You can see this. And you define the axis also. -5 to 5. Next, -1 to 5. Yeah. The red one is not at all appearing. So let me take -10 to 10. Yes. You can see here, for little more understanding, -2 to 3. So the red one is perfect function. What is the exact function? Sin x. With the fifth order, if suppose the function is with fifth order, that will be the blue. So up to where it is correlating with red curve. 10th order is a green. So compared to fifth order, it is giving the sine function more. The black is giving more than the previous. I'm not getting first one output. It is showing error. The first one output means exactly, may I know what it is? Is this f1 is equal to Taylor of gradient? We tried, right? This one. X square y cube z power 4. I'll explain that, madam. At the end, I'll explain you. So this is one after another. You can easily get to know that exactly how by increasing the order of the Taylor series, that series is equal to the exact function. So this is how we can easily compare. Even for academics, who can use these kind of tools to explain to students, or even for us also, how accurately it is giving near to the point pi by 2. Near to the point pi by 2, how it is equal. So this is how you can see. Okay, so this is one topic, Taylor series. And similarly, Laplace, inverse Laplace, Fourier, and inverse Fourier transform. Let me look for the Laplace transforms, Laplace and inverse Laplace transforms. This one. So Laplace and inverse Laplace transforms. So we need to symbol S and T. Suppose the function f is exp of minus t. Then Laplace of the function from t to s. Laplace of t to s. So e power minus t, Laplace transform. Or e power minus t into sin t. What will you get? 1 by s plus 1 whole square. Right? Or otherwise, you will take sin t plus 2. What will you get? You just change the function, then it will give the result. E power minus t sin of t plus 2. It's Laplace transform. So Laplace transform of the function f. This function is in terms of t, that you are converting in terms of the other domain. Yes. Right? Suppose inverse. What is the inverse Laplace? For that, capital F is equal to, let me take 1 by 1 plus s square. So inverse Laplace is I Laplace. Capital F, s comma t. Here reverse. Variable s, we convert in terms of t. You can see 1 by s square. You can give complicated also. It's like 1 by 1 plus s power 4. You see, 1 by 1 plus s power 4. Or s by 1 plus s power 4. What you will get? This is Laplace and inverse Laplace transforms. Laplace and inverse Laplace transforms. I think I'm a little faster, I think, today. So I'm just keeping in mind the need to cover more topics that may good for the participants. With that mind, I'm trying to give. Okay, so I'll try to explain slowly. Just to practice this, f is e power minus t into sine of t plus 2. No problem. You can practice now also. So these are simple, just 2 or 3 lines syntaxes for inverse and Laplace transform. The same thing for Fourier transforms also. Fourier transforms also. It's simply Fourier. F, t, comma, s. Maybe this is not working. Let me give the function here itself. F is equal to exp of minus t square. Then you can see this. Yes. E power minus t square Fourier. That is, participant is asking how to solve differential equations using Laplace transforms. You can do that, but here it is not one line syntax. That is not one line syntax. See, you have to apply the Laplace transform for every term, or otherwise the complete differential equation, you take it as an equation. To that equation, you need to apply Laplace. You solve that Laplace for s value and then apply inverse Laplace transform. That is not a one-line syntax. So it's almost 10 to 15 lines is required to solve the differential equations using Laplace transform. We did it. We are teaching to our engineering students how to solve differential equations using Laplace. This is a Fourier, and similarly, if suppose a capital F exp of minus s square by 2, then what is inverse Fourier transform? Capital F s comma t. You can see finding Fourier, Laplace, Z transform, these are easy. You just feed the function and you give the function transform from which variable to which variable, then it is easy. So Fourier from one variable to the another. Any transform, one from one variable to the another. And these are the direct syntaxes for this. Fourier inverse, Hilbert transform inverse, Laplace inverse Z and inverse Z transform. So symbolic preferences, that is, I think most of us don't use that for our academic or maybe research. But if you need it, you just search for this. What is the set symbolic preferences? Hessian matrix is Hessian only, Hessian. That's all. So next, we do the graph theory. How to visualize the graphs and directed graphs. So for any graphs, there are certain endpoints. For every edge, there are endpoints, right? So based on the endpoints, we do this. But let us see, to explain this, I need to take one example, one graph theory example. I'm just taking graphs in graph theory images. Yes. Take any example. Suppose a directed graph. This is directed graph. 3 vertices and 3 edges. Okay, 3 vertices and 3 edges. So vertices are labeled with ABC, right? Vertices are labeled with ABC. First, let me write what it means exactly. So it is edges, edges. Let me take, I think, yeah. Let me take a maximum font. Otherwise, I don't think it's appear. Yeah. Edges. What about the edges? There are 3 edges. And before that, vertices. When will we do Hessian matrix? To find definite matrix, positive definite or positive semi-positive, semi-negative, positive definite or positive semi-definite or positive negative, these, to find that we use the Hessian matrix. Hessian matrix, which includes second order partial derivatives, to find maximum and minimum values. Yes, one more participants gave the answer. To optimize the functions, we use the Hessian matrix. Function in terms of 2 variables or 3 or 4 or 5, for any variables, Hessian matrix will give the result. To know the maxima and minimum values for function of 2 variables or more than 2 variables. Yes. Now suppose here vertices are A, B, and C. Okay. So this is edges are what? What are the edges here? A to B. A to C and B to C. These are the edges. See, directly we can't give information using the ABC to MATLAB software. That is why I will take A is 1 and B is 2, C is 3. Now it's very clear, right? What are the input? What are the starting points of the edges? You can see here now edges is equal to 1, 2, 1, 3 and 2, 3. This is 1, 2, 1, 3, 2, 3. So these we divided to what are the starting points of every edge. Starting point of the first edge is 1. Starting point of the second edge is 1. Starting point of the third edge is 2. Okay. Next, terminal point, last point. Now, ending point of the first edge 2. Ending point of the second edge 3. Ending point of the third edge is also 3. Here, this is the edge 1, 2. 1 is a starting point, 2 is the ending point. 1, 3. 1 is the starting point, 3 is the ending point. 2, 3. 2 is the starting point, 3 is the ending point, like that. This is. And these will feed in, yes, here. So what is yes? 1, 1, 2, right? You take the vector form, sorry. Next, T is equal to 2, 3, 3, terminal point, 3, 3. Got right? Now, simply the graph of S comma T, that's all. Graph of S comma T. Now the graph is defined that we feed in G, capital G. That graph is defined and we feed it in this. But we need to plot this graph. You can see the plot of this graph. Yes. Let me take the new thing, I think. Why all are closing here? Yes. You can see the graph. Okay. This is. But see, suppose you know the weights of these every edge, weights of the every edge, if you know. Suppose let me take weights. AB weight is 3, AC weight is -2, BC weight is a 10, suppose. How you can give? Just simply give W is equal to, what is that? 3 minus 2 minus 2, 10. That's all. 3 minus 2, 10. So for this, starting point, ending point, and weights. This is. And you can see here one more thing. If you want, you can name it as A, capital, sorry, and B, next C. You can see what we'll get. Mm, Yes, node names only. Graph, MATLAB, error using omit self loops. Let me take this. Yeah. So now here, this is the file. So how do you get the file names? Yeah. So sorry, I forgot this syntax. You have to add this, then it will work. Yes. STW names. Names is correct. G. Okay, we don't give the comma. I don't think. Within braces, say that's why this is very important. So the square brackets here, why the braces it is asking means this is not the vector form. Why we use the brace means these are the symbols. Uh, Maybe in C language case, we'll call it as a dictionary. Brace we use for the dictionary. This is not an array. So the first node is represented with capital A. Second node represented with capital B. Third node is represented with C, like that. So it will read it as a dictionary. Dictionary can be given within the braces. So that is the information. Now you can see even the weights also we are highlighting in the graph. And you can clearly see that the vertices are not with 1, 2, 3. These are with ABC. These are with ABC. This is.
Excuse me, sir.
Sir, tell me, sir.
Sir, please explain weight.
Sir,
Explain weight.
weights means the edges value, edges information.
So
AC, yes, yes, once again, please.
what is G dot edges dot white weights over there? Dot you are keeping, what it means?
No, that is the syntax. In graph G, edges, weights, this is the syntax actually. If suppose you don't use this syntax, it won't give, because you are expecting what is the edge label. So that's why this is this G dot edges dot weight. This is nothing but in a graph G, the edges weights can be highlighted in the graph like this. If suppose you don't want simply only the graph you want means you can just draw the graph. It will show like this, A, B, C. It will show the graph like this. But we know that what is the AB strength is 3, AC strength is -2, and BC strength is a 10. That is why we are giving that edge label along with its weight. Okay. Next, the same thing.
Sir,
Wha-
then what is S and T, sir? S we have defined as starting points, right? 1, 1, 2. Where
These,
we have not
yeah.
shown them.
This is ST. But ST, we are no need to show here. We already defined the graph in G. The graph information is fed with the syntax in G. So the graph of all starting points of the edges, terminal points of the edges, and the corresponding weights, and those nodes are replaced with alphabetical letters A, B, C.
Sir,
Sir, tell me.
so A, B, B, C, I, C, 3, 10, minus 2. This is with,
Sir, it's not audible. Sorry. Once again, please.
sir, A, B, 3, B, C, 10, A, C, minus 2. Is it with?
Yeah, those are weights.
Okay, sir.
Sir,
Okay,
is
thank
it
you, sir.
randomly allotted, sir? On what basis the weights are given?
No, I took randomly. If suppose you have any problem means I'll execute as it is. Just I took randomly. These are certain label weights for those edges and I gave. But if suppose the problem is defined for certain edge, this is the weight means that we can assign here.
Okay, okay, sir.
Yeah. Now the same thing, suppose a digraphs, directed graphs. See, undirected graphs means you can take the starting point is any one of the endpoints of the edges. You can see the graph, what is appearing in the screen, AC. That means A, you can take it as a starting, or C, you can take it as a starting. But directed graphs means it's not like that. So we should be very careful. Let me check one problem. What is the directed graph? Example for the directed graph, and I'll try to draw that. Yes. Directed weighted graph. Yes. I'm just try to taking the simple one with less number of vertices. Yeah. This is only the less, I think. Fine. No issue. So let me take this. Yes. This one. But don't take 0. Don't take 0 for MATLAB. If 0 is a label for a graph, that you take it as 1. For 0, there is no meaning in MATLAB. You can't assign 0. You can take 0 as 1, 1 as 2, 2 as 3, like that. But observe here, what is the difference? So let me convert these in terms of, so what are the vertices? 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. But I will replace these vertices like 1, 2, 3, 4, 5 because 0 is not possible here. Now the directed edges. Now the edges are like from 0 to 1. Next 1 to 2. Next 0 to 3. Next 0 to 4. Next 1 to 3. 4 to 3. 3 to 2. But we are converting these with vertices 1, 2, 3, 4, right? So 1, 2, 2, 3, 1, 4, 1, 5, 2, 4, 5, 4, 4, 3. Yes, these. Now the corresponding weights of this 0 to 1 weight 3 only. 1 to 2 is 1. Next, 0 to 3, 7. 0 to 4, 8. 1 to 3, 4. 4 to 3 weight is 3. 3 to 2 is a 2. Yes, 7 edges, 7 weights. Now, and this one, what are the starting point from this? 1, 2, 1, 1, 2, 5, 4. These are the starting. Next, what are the terminal points? 2, 3, 4, 5, 4, 4, 3. This is. Now let us feed all these things here, but we no need to label with A, B, C, D. Let us feed with 1, 2, 3, 4 itself. Now let us see what we'll get. Yes, this one right. Now I will change what is yes. Starting is 1, 2, 1, 1, 2, 5, 4. 1, 2, 1, 1, 2, 5, 4. This is. Next, terminal points of this 2, 3, 4, 5, 4, 5, 4, 4, 3. Now, what are the corresponding weights here? 3, 1, 7, 8. 1, 7, 8, 4, 3, 2. That's all. We don't want the names. Now, simply we remove that names. In place of graph, we take digraphs. That is the only difference. In place of the graphs, we take the digraphs. Now, this is the digraph along with weights, directed graphs.
Even these are random weights, sir?
No, these are not random weights. As per these weights I assigned, it's not like random weights. From this graph, I took the corresponding weight, and you can see 0 to 1, right? 1 to 2 weight. So this is 1 to 2 weight is 3 only in the graph. I just Googled it. What is one of the example for a directed graph that I took
sir.
and I gave. Yeah.
Okay, sir.
How to teach? How to solve Asian matrix using MATLAB. How to find Asian matrix? How to find Asian matrix? Let me give that as your just yes. Let me take the same thing and let me explain you what is the Asian. This is same XYZ. So in place of this, we will take Asian. That's all. First argument will be scalars. Yes. This is the Asian matrix. It's got right? Also, could you teach it for wavelet transforms? I don't think there is a direct syntax for that. Direct syntax is not available for wavelet transforms. You need to use an integration formula, whatever the statement you can do. As I'm PhD scholar working on how to solve Navier-Stokes equations of continuity momentum, I need MATLAB code to solve this. Couple nonlinear PD equations. Could you please guide me how to get or send me code? So, see, it is very difficult of sending the code. I think you know my email ID. You can contact me. If suppose I'm able to help in that point of view, I'm ready to. This is my email ID. Yeah, I will guide. I will guide. You just mail me what you want, or otherwise you can call. We'll discuss it. Fine. So any more doubts? I'll try the Hessian matrix you told, right? Sorry, wavelet transforms. Wavelet transforms in MATLAB. I think there is no one-line syntax for that. How to search syntax commands in optimization? Just Google it, but at the end you mention in MATLAB. You will get what the syntax. See, there is no one-line syntax for wavelet transforms. That is why it is a difficult for these. There are toolboxes also for wavelet. You just Google it, wavelet in MATLAB. You will get some information. Accordingly, you can follow what your requirement. Yes. Any more? Any more doubts?
Can we get the complement of the graph, sir, once we draw the graph?
Complement of the graph? Madam, sorry, I'm not aware of that. Complement means?
Complement means the other graph in which the edges are not adjacent. If they are adjacent in this graph, they are not adjacent in the other graph.
Okay, got it. So that means what you means, first you need to know what are the neighbors of the node that you can separate it.
Okay.
Then accordingly you can find it's kind of finding a submatrix.
Means I was asking, is there any inbuilt command? Like
Yeah. So there is a command, but let me show you. Just graph theory in MATLAB. Just Google it, and you can see your graphs with undirected edges or directed edges. There are many informations here. In this, you can search whichever you want. Modify nodes, edges, matrix representation, visualization. Even you can find shortest path, minimal spanning tree. You can see here, using the syntax, you can find the neighbors. For certain vertex, what are the neighbors? Accordingly, you can extract it. So see, there is a syntax for the subgraphs. Maybe in the subgraphs it is available, I think, like this.
okay.
But you can search in Google, you will get one of the another.
Yes, sir. I'll go through and get back to you.
Yeah. That's fine, madam. That's fine.
Thank you, sir.
Yeah, see here, this is they mentioned neighbors of certain vertex. If you extract that, opposite that is easy to find. Please provide download option for YouTube videos. No, you see, it all depends on your account link to the YouTube. So that is not in my hand. So please provide download option for YouTube videos means it is not in our hand. It all depends on what account you are using to access the YouTube videos. Yeah, you can download. So any more doubts? This is the end of the last day of the session.
Yes, sir. Yes, sir.
Sir, any comments, feedbacks also, if you want to speak, you can please.
Yeah, feedback is posted in chat. You can see it. Okay, sir. I think with your permission, may I conclude the session, sir?
Yes, sir, please. No issue.
Okay, sir. We are so much happy, sir, for spending your valuable time for continuously 7 days. So many of the young research and students also got nice information from you. I am also getting a good message regarding your session, sir.
Yes.
And I also thank for every participant having patience to listen this wonderful session continuously for 7 days. The feedback is posted in the chat box. Please look it once. And the certificate will be provided tomorrow. With your kind permission, sir, I want to announce one thing. Tomorrow,
Yes, sir.
as I said, that there is a one session by Ashok, sir. All of them are requesting again. Please join the session. Make him a wonderful program for him also. Thank you. Okay, sir. May I conclude?
Mallikarjun sir.
Sir.
Sir, can we download free version of latest MATLAB?
Sir, maybe that licensed version means with a Gmail account only you will get 1 month trial version. But nowadays they are giving online e-installation. It's not like direct installation. If you want to
Okay.
get it that maybe from known persons or maybe certain unpirated websites are there to download, but
If
it
not
is
possible, you can
difficult
get.
to announce in public platform.
So if you can get from any persons working in a premium institutions, they'll have license like that. With their license, we can do. I think, sir.
Okay, sir.
Yeah.
Yes, sir. Like that is there, sir. I am using.
Yeah, that is the only possible because I am also trying for long last. No one is possible. Okay, sir. May I close the session, sir?
Yeah. I'm just thinking about any participants will speak
Okay, sir.
feedback.
We'll wait. Yeah. Feedback. Participants, please
Sir,
reply.
sir, can we draw the 3D vector field?
Sir, I messaged you. You questioned, right? For you in chat box, I messaged you.
Okay.
Yeah.
Thank you, sir. Thank you. Yes, sir. Yes, sir.
Mallikarjun sir, thank you so much. It was
Yes.
really helpful for all of us.
Yes.
And especially like whatever the basic things were there, no, that was needed.
Yes, ma'am. Yes.
Thank you very much, sir.
Yes, madam. Yes. Welcome. Thank you.
Mallikarjun sir, good evening, sir.
Good evening, sir.
Sir, before attending this workshop, I was like, I don't know about anything about MATLAB. So some 2-3 days I tried to attend online of like 1 or 2 days I attended after coming from the work. So I
Yes.
learned many things, sir. I was not knowing how to plot also in MATLAB.
Okay.
So I'm really grateful that I'm able to I got this opportunity to attend your workshop. Thank you so much, sir.
Yes, sir. Thank you. Thank you.
Vinod sir,
Yes, sir.
in future, please organize workshop related research plotting,
This is encouraging to research person
related
participation.
So
research work.
the research work means it's very difficult to get more number of participants.
Yeah, yes,
At
yes, sir.
least
Because
40
only those
yeah,
who
yeah.
will.
At least 40 participants are there, then it is easy to organize.
Yeah, yeah, yeah.
I'm also interested in research work, sir.
No, no, the research means the topics, maybe the graph theory point of view, or differential equations, or fluid mechanics, or maybe wavelet transforms, or artificial neural networks. It all depends on,
Sir,
because
if you,
every
As I said,
participant
I
is
was
not
telling
working
them.
on the same topic, right? That is the reason.
Yeah, I was trying for same things of particular topic, but I am in dilemma as you said. Many participants don't come, not really should be nice. Because at least 50, 40, at least they should. Next time I will arrange a specific topic, sir, as they said for research topic.
That's fine. That's fine. We do that.
Yeah, yeah. Because that's why I
Maybe
gave you the feedback line. Any suggestions and improvements? If you mention in the feedback, I want this topic, then I will look forward to this. Because for earlier program only they mentioned I need a MATLAB like that. That's why I raised it this way, sir. Depending upon
correct.
participants suggestion only, I am able to conduct, sir.
Yeah, you can plan boundary layer theory with theoretical topics, how to take the equations, how to solve using MATLAB. That you can try.
Yeah,
I'm
sir.
just giving example. So
Yes, sir.
Yeah,
any particular
surely, sir,
topic.
surely, surely, I will do, I will do, sir.
Yes.
Because it's depend upon not
Good
only
evening,
MATLAB,
sir.
sir.
Good evening.
Good evening, sir. Sir, we are very need of the boundary layer theory, sir, because we are doing research on that.
Yes.
Exactly, ma'am.
So in future, yes, if possible, you can provide that, sir.
Yeah, that's from my
Because
side
all
is
the
ready,
sessions
madam.
were good, sir.
Yes.
Yes, sir.
So with the theory
Because we
topics, I'm
learned a
ready to
lot
explain.
from this. Yes, sir. Yes, sir.
Yes.
From 1 week, we learned something regarding MATLAB, sir. Because we are need of that MATLAB.
Sure, madam.
Because we don't know that basics in the. Okay, sir. In future,
Yes.
if possible, please, sir.
Yes, madam. Yes.
Okay, sir. Thank you, sir.
Through
Okay.
be in touch
Thank you
with
so much, sir.
Vinod sir. Sir
Yeah,
will
surely,
follow that.
especially being as a I'm as a fluid
Yes,
and
sir.
mixed
From sir
domain.
only we got this opportunity to join this, sir.
Yeah, yeah.
Yes.
Thank
Fluid
you,
and
Vinod,
mixed,
sir.
especially. Yeah, madam. In future also,
Because
next
all are
in
doing
future.
FD only, no, sir.
Yeah, yeah, yeah.
Correct.
I will
Correct.
organize regarding
Maximum
fluid
are
and
doing
mixed
on
domain.
FD, sir.
Yeah, yeah.
Yes, sir. Yes, sir. Thank you so much, sir. Vinod, sir, and Mallikarjun, sir. Thank you,
Yes,
sir.
Thank
madam.
you.
Sir, is it possible to conduct MATLAB in optimization, sir? Optimization techniques?
The optimization techniques, actually now I started off learning, but I'm not familiar to that. But if you have a doubts, means you can send. Even I also will search, will get the information. I'll forward it.
Okay.
But right now I'm doing the gradient descent method optimization. It's not like genetic algorithm or maybe other optimizations.
Okay, sir. Thank you.
Yeah, there are many optimization techniques, but right now I'm looking on gradient descent method only.
Okay, sir. Thank you, sir.
Yes, yes.
Thank you, Vinod sir and team for this wonderful session.
Thank you, madam.
Yes, sir. We can close the session.
Okay, sir. Once again, I will convey my thanks from my side and our institution and also from
Ye-
participants, sir. Thank you very
Yes,
much.
sir. Yes, sir.
It
Thank
is
you.
very good start, sir, because continuously with even though holidays we have got 3 holidays. In the 3 holidays also we have stayed your information, sir.
But I
So thank you,
really
sir.
appreciate the participants. Many participants actually practiced simultaneously, asked the doubts. So
Yes, yes, yes.
that is more interest to speaker also.
Yes, sir,
Otherwise,
yes, sir.
it looks like a one-way
Yeah, yeah, yeah.
presentation.
Yes, sir, yes, sir.
It's not a theory to present from one side.
Yes, sir, yes, sir.
Yes, yes.
Okay, sir. May I close the session, sir?
Yes, sir. Yes, sir. We'll close.
Thank you.